Hello everyone. Welcome to Krhom Shop Live, where we repair electronics, FPV electronics, or we die trying to. How are you guys doing? I see that we have the usual suspects already in the chat. Can give you a quick summary of what happened last week and what happened since. So last week we concluded the episode by having was a very good episode where we fixed a bunch of stuff, AIOs, and I was looking at this flight controller. Actually, that's the flight controller, and I want to show you. Basically, I was very confused looking at it because I was trying to find where the 5 volts was coming from. I couldn't find it, and let me actually show you in the overhead and zoom in a bit. So we have this thing, and it has a coil, which is usually what you're looking for to see what's the back and where voltages come from. And it has one, but it also has pin labels for 10 volt and 5 volt. I thought, like, okay, so is that a 10 volt that gets regulated down by some kind of chip to 5 volts? It usually would be a back, but here there's only one back, so I looked up the parts, and that's a 3.3 regulator that powers some things. That's also that's part of the back circuitry that does 10 volts, and I probed it, and it is the 10 volt back. So where is the 5 volt back? Well, it turns out there's no 5 volt back. This has 5 volt in the plug that goes to the ESC, and the ESC is supposed to give it 5 volts. Once I figured that out, I was able to test everything, and it all works. It's actually an old FC. I think it was given to me just because it was old and useless. I managed to flash it to modern Betaflight, and as long as you give it 5 volts, it's going to work fine. And it turns out I also have in the bin this ESC that has 5 volt. It has a 5 volt back in the middle here. And it has 5 volt out, so those pair together, and they can fly fine. This works, I tested it. So yeah, that goes in the box as a set, basically. You can fly them, but if you want to fly this alone, you would need an external back. And yeah, that's it. So mystery solved. It's actually working hardware, so it's all good. This goes in the box. In the box we have the AIO we fixed last time. This flight controller, I think we fixed last time quickly. Yeah, there was a cap, short caps, and it was a very interesting fix actually. Another 20 amp AIO and a bunch of ESCs. So yeah, we have a few things. Another thing I wanted to mention, what was it? Yeah, I'm currently working on off stream, I'm working on a personal project that I can tell you about because it's fun. So this here, that's a hot plate to warm up the hardware, and this is a Volterra ESC, and as you may see, it's lacking a few FETs. It's missing a component here, it's missing a driver, bunch of stuff missing, lots of capacitors missing. This is a Volterra Mini that drowned. And it was in my parts bin as a donor for the longest time. And for those who don't know Volterra, they are a European designed super high quality ESC that's made by someone I get along well with, and really nice chap. And it's a passion project for him. It's a very good hardware. And it's not cheap. And I was kind of sad to see it be in my drawer and do nothing. But it had a bunch of pads that were corroded away. It spent about 20 minutes in filthy water. So it was pretty much unsalvageable until I decided that I was going to salvage it. So I've been working on this, probably I have about 4 hours on it, something like that. I've been, so you might not be able to see here. I can show you under the scope, but yeah, those are tiny components, and I've been repairing traces. A bunch of traces were corroded away, so I had to create new pads. I had to kind of scratch at the rusted copper to reveal good copper when there was some. And yeah, I've replaced a bunch of parts, and I have ordered everything I need to fix it. That's the nice thing also of knowing the person who makes the ESC means I can ask for specs and things I need to put where, and I know exactly what FETs I need to put where. So yeah, that's been great. So that's an ongoing project. I'm not doing it on stream because it's just way too slow going and it's not very interesting. Lots of tedious work, changing tiny O201 components, probing, comparing with the donor, with a known working one. And yeah, so I'm just waiting for the parts to arrive, and that's going to be, should be a fix. There's no reason it wouldn't, given enough time and patience. But yeah, that's something I've been working on the side. Today, we are going to be looking at those two that were given to me by a viewer who generously sent them to me absolutely on their own initiative. It's super appreciated, and I will be looking at both of them. One of them, I believe, has an ESC issue, which I'm not sure exactly what, but we're going to test stuff. And the other one has supposedly been in water and the UARTs don't work. So we'll see if we can fix that or if it can work good enough on other UARTs. All right, so I think we have a few people in the chat, the usual suspects. We have Neo, we have Spawny, we have Surf PV, we have Agrif Gore. I don't think I've seen your name before, so hi, welcome to the stream. And Spawny says, thanks for the tip. Armata Productions has splendid service. Well, good to hear. I am planning to possibly use them. I have a few frames I've designed that people have asked me things about, so I might put them up on there as well at some point, and some projects as well. But yeah, that's a good way to share designs as well and have people be able to order them. So yeah, glad it's working for you. All right. I think we are going to be starting on those AIOs. So first, Paul of course is going to be USB as always. Well, let's do a physical inspection quickly, and then see if we can see the corrosion, see if we can see stuff, see which one is which. They are, thankfully, one of them has a black plug here, so it will allow us to distinguish them. I have tried to strip as much as I can of the conformal coating, but it looks like there's still some. But yeah, let's put them in and see if we can see anything damaged. You can see the conformal coating peeling up in some places. I did soak them in IPA for a few days, and this has damage on the cap. Let's do a continuity check on some of those. There's some amount, but it could be just in the conformal coating. Yeah, it doesn't look like it's damaged in any way. Otherwise, I mean, the fact that it's rusted here, that must be the one that spent some time in water. Because basically anything that's on VBAT, so I can tell you already, if I test between any of those blackened side and positive, it's going to beep, should beep. Yep, so that must be positive. This one must be positive. And the other side will be ground. All right, so yeah, nothing. And that conformal coating is thick. All right, yeah, nothing I can see. That conformal coating is going to be annoying if I need to replace parts here. You can see I'm able to remove some of it here. So, Windborne flash, now it's the data flash, the black box. Yeah, we have a bunch of drivers for the fence, is it? No, that's tight. Oh, 2 gyros? No. Is that 2 gyros? Oh, there was a ball of solder here. That's not good. What the hell is this hole? What's this hole for? I've got tweezers so I can recover the ball. That is. Very strange indeed. NewbeeDrone, they do weird things. I mean, this whole board is just weird and kind of stupid in some ways. But they decided to put a hole in the middle of their chip. Is that an LED? I don't know. Doesn't look like it would be. I mean, how would you even solder a component at the bottom of the hole? I don't know what that is. Can we see anything damaged? Nope. Nothing damaged. And a small bunch of conformal coating kind of crud here. Can we? Doesn't really matter. Yeah, okay. Can't see anything especially bad. Doesn't seem to be much corrosion. No, it's just a conformal coating. All right, let's see if we can see damage on the pins, like rust in the pins. Nope. Okay, this seems kind of rusted, or that like gunky. Doesn't seem really damaged, like rusted away in any way. But yeah, okay. Let's have a look at the other one. So that's the black one. Let's have it at the white boy. Looks like this one I managed to remove the conformal coating way better. And nothing, it looks very, very clean. I'm not sure those boards have flown a ton. Yeah, I managed to clean this one. So maybe the other one I forgot to put in the alcohol as much. This is, apart from some places like here, seems to some stuff. What the hell is this chip? This was laser etched. They used a laser to remove the labels. We don't know what that is, which is kind of scummy. It's just such a weird thing to do on an FPV part. Yeah, so those are not the gyro, they're just the backs. Not sure what I thought. Where's the gyro? What are those? That's a bunch of weird. I'm guessing those are the 3.3 volt regulators. There's one for the STM, one from the OSD chip that must be somewhere, and one for the gyro that must be somewhere. And yeah, where even is our gyro? What even is our gyro? Is that? Weird board, NewbeeDrone, doing weird things. Okay, I can't see anything bad. I'm gonna plug them in and see how it goes. Oh, Spawny, sorry to hear you're in the hospital. Hopefully everything's okay with you. Hopefully get better soon. And obviously, if you're tired, absolutely feel free to dip out. I know you're always there at the start of the stream, and that's very endearing. It's very nice to have people around. So, just a wound to heal. Okay, and it's just time then. Time will do its thing. Let me plug those in the PC and see what we get. Obviously, because it's NewbeeDrone, it's not USB-C. It has to be USB micro beam. I'm gonna do the. No, I think it told me they were still connecting, so I'm gonna take the risk and plug them into my PC directly. Okay, that's the thing, and let's have a look. Okay, it has its own special name. It does still show us Steam electronics though, a bit of light. Okay, that part works. And what's the driver? Let's see what the driver is. Does it say here? Status should tell me. MPU 6000. Okay, that's an MPU, which I very much dislike because it's not been produced for like 3 or 4 years, and quite often these days, MPU 6000 brand new boards have defective gyros. So yeah, I don't trust the MPU 6000. I know people who fly FPV, have been playing FPV for a while, swear by it, but I haven't, and I do not. I have seen them fail too often. So let's try the other one. Still seems to be doing its thing. And does it connect? It does. Different COM port. Okay, so and that seems to be working. So from what I've seen from the email they sent me, one of them can't reach the ESCs and has defective ESCs. So let's see if we give them power, whether we can communicate with the ESC. So let's disconnect here, set it up to give it power. We're gonna be giving them 4S with overcurrent protection on, as to not fry it. Hey, Killian. And do they even say which? Oh, they do say which one is plus, which one is minus. Thanks, thank you, NewbeeDrone. I wouldn't put it past them to not say it, because they do weird shit. Right. So that's the white one. Now what we're going to be looking for is 2 things. So let's go to screen share. So first thing, we'll be looking at whether the communication between ESC and flight controller is good. So as you can see here, there's no red numbers. That's because bidirectional D-shot isn't enabled. So let's enable that. Hey, MacShaky. Oh, sorry to hear you're not feeling so well. But obviously, health comes first. So yeah, don't hang out too long if you're feeling tired. But you got your Microscope a few days ago. Yeah, that's cool. Hopefully you can get some repairs going, and let me know if you do and if you need any help. I'll be happy to help. All right, so now we have. Okay. What? That's weird. That's, yeah, I mean, NewbeeDrone, I guess. So here I was expecting full red numbers because ESC is usually on powered up when you don't have when you're only on USB. But apparently when you're NewbeeDrone, you power them up regardless, which is fine. It's not the first time I've seen it, but it kind of saves on voltage regulators, I guess. But we have one that doesn't respond, and let's see what happens when you give it juice. Okay. And yeah, so we definitely have an issue with ESC1, which let's see. Let's reset. What I'm going to do is reset the board so that any reordering of the motors goes away, and that way we'll know that 1 here will match 1 on the board. So to do that, I'll just go to the CLI and type defaults. That's going to reboot the board. And now we can connect. Yes. So yeah, I need to re-enable better bidirectional D-shot. Wait. Oh, they don't even have a good target with the right protocol selected. I'm glad. I'm going to be bitching about NewbeeDrone a few times this stream. I'm sorry if you're a NewbeeDrone fan. They make great stuff, but they also make so many dumb decisions. And yeah, like they have like a non-conform stuff. They make their own standards when it's really not needed. Yes. And they like this whole board is just a bit of a mess because it has the USB where it shouldn't. But yeah, we'll continue being baffled by them. So here, yeah, so it's still 1. So let's see what we can see about whether we can see something shorted around ESC1. Because if that's not responded, then that's probably what the issue is. And we know where to start looking. Let's go to the scope. So the ESC side is this one. And motor 1, do they label their motors? I mean, yeah, they don't. All right. So motor 1 in a normal quad would be this one. So bottom right. So let's see if we can get any kind of info about motor 1 here. But it might not be the same because, yeah, NewbeeDrone. But it would be this MCU, possibly. I mean, what it looks to me that it would be this MCU because it looks burnt. What we can do is have a quick look with the thermal cam, actually. Let's do that. Let's do that. Might give us some more info. So hook it back up to power. And we'll use the thermal cam if I can grab it. All right, can we see something? Turn it on. Okay, we can see 3 of them. Kind of the 4 of them, but they're the driver chips, I think, turning on. Yeah, they're not the MCUs. One MCU seems to be colder than the rest, possibly this one. I don't know, it's not clear. It is not clear. Can't see anything very obvious though. See on the other side. Yeah, just the BEX, power regulation. Nothing to worry about here. Oh yeah, no, I think the chip they lasered off must be the MPU, and they just don't want us to see that it's a fake MPU clone or something like that. Has to be some. Yeah. So. Yep. Nothing obvious here. Let's see if you can probe some voltages, maybe. We know it's powered from USB, so let's power it from USB, and we'll see if we can read something. Hola, Big. Comment está? Salut, Big. Bienvenue. AWAG. Hey, AWAG. You love those NBD AIOs? Well, apparently they don't love everybody back, because 2 of them are burnt. But yeah, well, looking into white at the moment. Hey, Danza. Let's see if we can figure out which one is then getting powered. So I'm gonna be using USB to power it and see if we can poke us at the voltages and get some information. I hate where they don't mark the plus and minus on both sides, so I'll have to remember which one it is. So minus is on the right when we're upside down. So I can probe ground. Okay, so let's give it some USB juice and go into voltage mode. DC volts. And let's see if those pads they've exposed are, I already forgot which one is ground down. I'm too dumb to remember that case. Right one. So yeah, we'll see if we can see some voltage on those pads. So nothing here. 3.3. So we can see voltages on the second pad, and those are going to be. Well, that's 3.3. Okay. That's going to be 0, 3.3, 3.3. So that might not give us the information we need, because it might be still getting 3.3. Okay. And they're all getting the same reading. Okay. So one of them is not communicating. I'm guessing it's either that the MCU is not lighting up. So I need to find the pinout of those MCUs, but we can probably just probe. There should be 3.3 on one of the legs, so 1 volt here. But I still don't know which one it is. So 3.2 on the pin -3, I guess. Let's see if that's the case for all of them. Yeah. Right. Yeah, we are getting 3.3. Okay. I think that's just crud. Anyway. Do we have a way to know? Yeah, I have a way to know. I can just hook up motors and we can figure out. I think that's going to be the fastest way. I'm going to have to spin some motors and see which one don't spin, because there's no good way to know which one motor one is exactly. They're not labeling them. So let's do that. Let's do that. We have a special print for us today. It's a thing that lets me put some AIO on top of this rig, so I don't have to do any weird gymnastics to get stuff on there. Right, let's put on some extra solder. And then I'll solder the wires and we'll know which one's not working. Right, tweezers. I really need to spend some time redoing those motor wires. They're incredibly wide. Yeah. Let me actually grab the correct tip for my iron. Let's use This guy. This guy. Right, that's the fun part of the stream that everybody is looking for every time, soldering a bunch of motor wires. Everyone's favorite moment, full of, can't even find the right words, full of excitement. That's what I wanted to say. If there's any question related to FPV in general, repairs, how to diagnose stuff, how the stuff works, this is your moment. Because I am looking, what solder do I use? So what you want, I feel like, really strongly feel that the brand doesn't matter as long as you don't take fake solder. There are a bunch of fake solder on Amazon and possibly other places. Right now in my spool thingy, I have some TBS branded solder and some Kester branded solder. Kester is one of the most recommended brands in the US. I wanted to see if there was any difference. I can't really see any difference. The things that you want to be looking for, the important bits in solder, is that it needs to be 3763. That's the mix of tin to lead. So you want leaded solder. And that specific mix is called eutectic. It means the solder goes from liquid to solid without going through a pasty stage. So that's the thing you want to be looking at. And you want solder with some flux in it. So it's going to say flux core, no clean flux, leaded solder, 3763 is what you want. But yeah, brand doesn't really matter. But yeah, if you get one of the from an electronics supplier, you're gonna get good stuff. But the TBS one is good. It does the job. I don't know exactly what you have access to in the US, but yeah. All right, so we are soldered. Let's give it some juice, and we should see on the race wire LEDs immediately which one is not working. But we will spin the motors to see if we have anything weird going on as well. Might as well. All right. Let me zoom out a bit. 3, 2, 1. What? There's some crunching going on. And that's all extremely crusty. There's nothing working well. That's... It's AM32. It's AM32 on there. It's not BL32. Yeah, so... let's give it some... Let's plug in through USB. But it all seems incredibly broken. It all seems incredibly broken. We'll see. So let me try to spin. Motor. So motor 1 we know is not responding well. Let's try to spin motor. Motor 4. Okay, that's spinning smooth actually. Okay, that's good. Motor 3. Spinning smooth. Motor 4, motor 2. That's not spinning super smooth. I can see also it takes a while to slow down. Maybe some settings in AM32. Okay, we'll see. So, and motor 1 is not doing anything. So that's this one, this guy here. So we know it's the one next to the USB port that we're looking at. All right. So, I mean, first we need to start restoring, see if we can restore that communication, because without the ESC and FC communicating, we won't be able to do anything. I might have some donors, but we need flash AM32, which, like the right target for AM32, which might not be the main thing we want to do. It takes a while, and it's something I could do on stream one day, but that's not the focus of this. So I'll see if I can find out. What I'm hoping is that the MCU itself is fine, and there's something shorted around it, and like the driver maybe, or something like that. And if that's the case, then we don't have to replace the MCU. If I have to replace this MCU because it's AM32, then I can, if I can find a donor. It's not closed, but it is definitely a more involved task. So one thing we could do is steal the MCU from the other board if we can't fix that one. So what I'll do is try my best to see if something's broken here. If I can't find anything, I'll switch to the other board, see what we can do there, and decide what else we might be doing today. Thank you very much, Spawny. Great evening to you too. Neo is asking, why is O4 light so fragile? Why are you so rough with it? It doesn't break if you keep it in its box. Okay, so the one next to the power, the USB port. So let me see. I'll go to Microscope. So that's going to be this one. It is the one that's kind of roasted. Let's see if we can detect some shorts. Let's go short finding. Yeah, I'm hoping it's the 40-year-old chip, because I have a bunch of donors for those. But now let's go to continuity mode. All right, so let's see. Start poking at stuff. And so I'm guessing, so let's have a look at, I don't know if this, so that's the driver for the chip, for the thing that's not working correctly. I should be able to find a pin, so it's going to be a pin on there that goes to the gate of this. It doesn't have to, because it could be the gate resistors that are dead. Is that not the gate on this? Yeah, that is the gate. Right, they might have put the gate resistors on the other side too, which makes it harder to debug. But where can I start? Wait. Now, this one might be a fairly involved analysis. That might take me a while to figure out. So first of all, I want to see which one of these. Oh, I know this one is the one. Yeah. Yeah. So this is the chip. That's not working. Not this one. Not this one here. So those are working together. You can see the traces going from each of them. So let's have a look. Let's see if we can find shorts on. So yeah, so that's, I'm on ground. Let's see if I can find things that's shorted on the MCU. There should be at least one pin that's ground. No pin that's ground. That's a mystery. There's bound to be at least one pin that's ground. Right? That's surprising. Let's see test on one of the other ones. So the pin 4, did I miss pin 4 being ground? Yeah. Okay, pin 4 is ground. So now I should probably look at the data sheet for this thing, but it's kind of a pain to look up data sheets on stream because it can take a while to find the right information, which is a bit boring for you all. But I might have to do that. Testing some caps, some resistors. It's just a 10 ohm resistor, that's fine. That's probably a 10 ohm resistor here. 10 ohm usually is a gate drive. Oh yeah, those are the gate drivers. Yeah. Just testing them quickly. But they wouldn't be causing the lack of communication. And yeah, I'm not exactly sure what pin would be communicating to the MCU. So let's have a look at the data sheet. So it's a G071 GB. So what was it? I already G071 GB. So what I want to be able to check is the voltages are all present where they should be. And so I can show you. I'm going to be looking at the data sheet. Now there should be a pinout somewhere. And those are pretty beefy though. Like STM32 datasheets, they are long. Those are very capable MCUs, so it's not surprising, but at some point there will be a datasheet, a pinout. That's not it. There we go. And so we can see, wait, top view. Why do I have ground on VSS, VSSA? Is that supposed to happen? GUN. Is that our version? There's many. Okay, which version do we have? What was it? We have a GB. No, that's G07 GXU. So, and we have GBU. GBGQ. It's not the right one. Many different packages. Yeah, I'm not exactly sure which one it is. Am I even? Yeah, so I'm not even. That's where me being self-taught doesn't really help, because I'm guessing one of them is probably the right thing. KXU. KXU, and this is GXU. I'm feeling this probably is the right one. GP version, GXU, and we have GXU somewhere. Not really. So yeah, I'm not really sure even what we have. Like, we don't even have a GND, so I'm guessing VSSA or something is done. Yeah, I need to learn more about STM32 stuff. I don't think that's going to help a ton with my current knowledge. So that's something I'm going to have to chat to people about and go online and learn. Well, in the meantime, what I can do, just because it's kind of a hunch, is to remove the driver chip and see if we get communication back. And just because I could see a damaged driver kind of stopping the thing from booting, but at the same time, it's kind of dumb to remove a perfectly fine driver. I mean, I can always put it back. There is a plug next to it, which is going to be annoying. Let me poke at it a bit more, but and yeah, I couldn't find anything else shorted, but I might not have touched it as good as I should. I just want to see if I can find a discrepancy between this and the neighbors. Also, would be nice if I knew which pin communicates to the MCU, see if the communication is broken in some way. But yeah, without knowing the schematic, it's going to be hard. So what I can do is like reflow it. That has been known to fix stuff when there are slight cracks in the soldering. I'm not very hopeful here because it's a thick board, so it doesn't tend to deflect much, but you know, what do I have to lose? I am going to put something over the port to protect it. I'll start by reflowing this. And we'll see what happens then. Let me take some foil, from aluminum foil, sticky aluminum foil. I'm going to use that to protect that kind of stuff. If I can, if I manage to peel it. Oh yeah, it's just all broken up. Yeah, I can use a piece of it to protect this to some extent. I mean, if I insist on if I stay too long on the heat, it's not going to do anything, but it can help protect it to some extent. Don't want to put it too far back. Otherwise, if I want to remove the driver, then it will get in the way. Right. Right. Let's reflow this and see where we get in from there. Actually, now I think about it, I think the MCU is probably fine, because when I was trying to boot it, to boot the AIO, I could hear some weird noise coming from that motor, so. I'm not super familiar with AM32. It's possible that when the driver doesn't boot correctly, it doesn't start. Yeah, we're melting. Not molten anywhere, everywhere. Not molten, yeah, I think we are molten everywhere now. Or close to. Let's see if I can slightly nudge it. I can't? Why can't I? It's still not molten. There we go. Now it's all molten. Okay, let's see if that did anything. I'm not very hopeful, but you know, you have to try. You have to try. Next, what I could do is remove, if that doesn't do anything, remove the driver, see if I get something. Then if I remove another driver, which I can always put back, I'll see if the other one goes red, and I know that missing driver or faulty driver causes it to go red. Let me cool the board down. Awag, you're asking whether it's worth to hold onto a board. It has a few bond components. Yeah, it's absolutely repairable. I would hold onto it and either try to fix it later when you want, when you learn the skills, or give it to someone who can fix it for you or wants to learn. As long as it doesn't have a crater on it, it's probably fixable. That's the board cooled down. While I'm here, might as well check any, do a very quick continuity check on the FETs, because you know, might as well. So that's the usual. I'm gonna check if we have any shorted FET. So that's gonna be on those three between plus, but we don't. I can double check if you have, quickly check the body diodes. So that's gonna be, so that's minus. So this should have, so I'm putting my red probe on the ground and checking this, and this should read like 0.4, all of them. And if I click the other probe here, 0.4, yeah, okay. Okay, let's plug in USB and see if we get anything different. Oops, that's all blurry for y'all. Okay, so yeah, we're gonna go to the Betaflight. We're gonna see if we can get anything different happening. Yeah, still the same. Okay, so I'll remove the driver quickly, and then if that's still red, I'll remove the driver from another one. And why did I remove this? Why did I remove this? I'm going to try to heat from, if I can reach. I'm going to try to heat from the left as to not, or from the top actually. It's just going to burn myself probably, but let me heat up the board a bit. I'm going to try to go from the top as to try to not, maybe from the side, try not to melt the port, reduce the chances of melting the port. So let's go in. And I'll wait till I see the molten balls and remove it. Now we are getting close. I am burning myself. Weird how they put the ground pad only on the side. It's just, NewbeeDrone, doing NewbeeDrone things. They do have a nice marker for pin 1 though, so that's good. That's the dot. Okay, so let's see if we get anything, any error still. I'm gonna cool it off. Yeah, you're absolutely welcome, Awag. I'm always happy to help people out. That's what I do. So we were kind of doing things in order to learn stuff, because if I have to remove the other driver just to learn whether removing a driver makes the thing go red, then I know for sure, but yeah, so it's still red here, which could be normal if removing the driver does this. So I'm going to go and remove another driver from another one. I'm going to remove this guy. And we'll know for sure if it's the driver or not. And if it still doesn't communicate, it's likely the MCU. What I could do also is swap two MCUs and ensure that it is indeed the MCU, but let's start with removing the driver, and we're learning stuff here. It's not a very cool thing to do to that poor chip, but that is one of the reasons I can't really take repairs to order. But people have asked me to repair that stuff, but I'm still learning. I still have plenty of learning to do. And sometimes I just want to be able to take stuff apart in order to learn how it works. Right? So the known good one is going to go on the left. Okay, and now we want to see if we get two errors. And if we get two errors, then we can place the known good thing on the old bad slot and see if that fixes it. Let me cool it off again. Still very hot, but should be, yeah, I probably should cool it off a bit more. It's just warm now. All right, let's go again. Let's see if we get one or two. Okay, only one, so MCU it is then, very likely. Should I move an MCU from one to the next? Yeah, probably should do that, just to see if we can move the error. And I'll remove the bad MCU and put a good one where the bad is. I should probably also put back the drivers. Might as well. And yeah, let's have fun. Why not? All right, so let's put back the drivers first. We'll just flow them back where they were. Easy does it. If after all of that I haven't melted the plug, it's going to be a miracle. So, yeah, so you can see a white dot here is pin 1, and I can see the pin 1 here, so that's the right thing. Let me heat up the board. I'll heat up the board, then drop the chip in place, and then reflow it. I'm burning my fingers. Okay, that wall. I need to do something else. I need to move that aluminum wall I made is redirecting the heat towards my fingers, which is awful. I'm just waiting for the pads to go shiny, or most of them. Then I will drop the chip. And it's dropped, it's not located properly. There we go. Now I'm going to put some more flux and reflow it. And then press on it to make sure it makes full contact, as I had issues with not putting them right before. So here I'm waiting again to see the shiny balls. Everything's melted, especially this one here. That's the one I'm looking at the moment. That's definitely not melted. We should see it move it and settle into place better as well, hopefully. Next one's melted. Now it's all melted. Not fully melted though. Take some push on it. There you go. And now I think we are fully seated. Yeah. I'll remove that ball later. Actually, might be able to do it now while it's very hot. There we go. And just sucked it up. Let's go up there and put that one back. We'll do everything while the board is hot. So here we have the pin 1 that's bottom left. So we need to put this. That's correct. Yep, that is correct. So I'm just same as going to try to tack it in place first. I'm melting some of the so now it's going to be tacked in place and come in with some more flux and wait for everything to melt, because that's not even remotely close to being correct in terms of position. Just waiting for it to drop into place, basically. And I'll push it to the right a bit. I am on 400 degrees, by the way. Does it matter? Trying to not burn myself. It's not molted here, that's one thing that's not molten for the ground. There we go. Now it's settled into place. I can push on it and wait for it to solidify. There we go. We have a few thick pins. Just touch them up quickly. And let me put some flux on that. Can do a quick sweep just to make everything clean. Let's try not to remove the cap. There we go. It's nice and clean. Now, I was talking about removing this and putting another one in. Let's put this one to here. So this one is the right orientation. Yeah, let's remove this one because we believe it's broken or it's damaged in some way. Wait for stuff to become shiny and show us it's melted. Should be fairly soon now. There you go, so that's probably dead. Let's go and get this guy. That's good. Let's put it up there. Put some flux. So here it's tucked into place. Now I need to push it to the right location. First. There you go. I'm going to push on it. Oops. Go back. I might not need to push on it actually. I'll leave it where it wants to settle. Seems well connected enough. I don't really need to push on it. So might as well not do it. All right, so now we should see ESC1 appear and another one disappear, and hopefully. Yeah, hey Droneo, yes, so much flux. Hey Quebec. I wish I had some baguette right now, but I do not. So much flux, yeah, it's not actually that much, it's just very zoomed in, but we drown stuff in flux when we repair. That's how it works. And forget to remove the USB cable. So now I have a USB cable that's about 200 million degrees and might not work. I might have broken it all. That's something I overlooked. I'm pulling down my USB cable. I am going to test with the other board whether my USB cable still works. It does. Right. So I'm guessing the STM32 overheated on the other side while it was powered up. But yeah, all right, so let's cool down the board and see if it still responds, or did I break it by leaving the power in? I'm not used to powering them from USB, so. I'm also curious at the state of the plug. Did you see that after? Because that's the only way to get UARTs and stuff from this board. It's the plugs. There's no other way. There's no pads on this board. It's just did I say that it was a very dumb design? It is a very dumb design. Okay, seems like it lights up. Yep. All right. Moment of truth. Do we have? Yeah. Now we have this one that's dead. So it is the MCU. So question is, do I have any of those? And can we program them? But first we'll see if we can fix the other one. And yeah, so we'll see if we can fix the other one. If we can't, we can just borrow one of the MCUs. And if we can fix the other one, then we'll see about finding a donor. I'm pretty sure. Let's have a look. And at that point, we can just reprogram it with the correct AM32 firmware. But let's have a quick look at the bin, and I'll bring them on under the microscope. And we're looking for G0 boards, and I do know I have at least one previously AM32 board in there. That would be G0, and some BL32 boards can be G0 as well. And where's my AM32 board? Oh, that's an AM32. That's a Goku board. Do they use? No, that's artery chip. This one, that's artery. What about SpeedyB? Oh, SpeedyB is 8-bit. SpeedyB is 8-bit. That's a F0. This one is hard to read. F3. This one is 8032. What about fly collar? G0. Yep, that's the one. So yeah. So we have a donor here. So we can actually save it. It's just going to be a bit more involved if we need to pull from there, because it means we need to pull an actual, like we need to flash it, but that's very doable. All right, so I'll keep that around. It's funny because, oh, I forgot to put the microscope view, but it's funny because the donor is actually the same color as the other AIO, but yeah, this has the correct MCU. But let's see what we can find about this other one. Oh, also, let's go to the microscope and see if I completely melted the plug away or not. Or did we do a good job? I think we did a good job protecting it because it's intact. Good, good, good. Aluminum foil does the job. And I have never used it to that extent before, heating up the board a ton, so I'm happy it did. This STM chip is dead. All right, so this board. Let's have a look in the plugs, because so this one has spent a bit of time in water, and supposedly the UARTs don't work anymore. So let's do a quick motor check on this one. Let's see. Let's confirm that the motors work. That is something that has to be done anyway. So let's do it now. And we are back to the most fun routine of soldering motors. And yes, I did look into doing alligator clips for motors, but like, look at those pads. You couldn't even begin to fit an alligator clip on a bunch of them without all of them popping off. So it is just unfortunate that we can't do anything better than soldering motors. Doesn't have to be pretty, but it has to be done. It's now again time for questions, if any of you has any question. I think, in theory, like apart from the weirdness that NewbeeDrone does with this AIO, that the fact that you can't solder to anything because they don't have pads for stuff and you have to use their weird thin cables with a bunch of wires and everything. Like the electronics design looks very solid and they're using super high quality FETs, I believe. I haven't looked them up, but that is what they say. And I could see like, there's no reason this couldn't fly 5-inch. I do fly 5 inches on AIOs. I even have one that's been bashed in bundles that's on the SpeedyBee AIO. It's doing fine. So this being like straight, as long as you use a USB length, like you deport the USB somewhere else in your frame that is accessible, then you can just use it as a normal AIO. A normal normal AIO in your 5-inch build, and it should fit perfectly as long as your frame can do AIO mounting, of course, which a lot of frames don't. But yeah, I could see this. That would be worth trying on a 5-inch. I mean, if you get it from the box, it's only €5. So because I think when you buy it, it's ridiculously expensive. It's understandable. They put a lot of stuff in it. They even went through the trouble of lasering off the fake MPU 6000. Well, I do need the power to spin the motors. I do need the power. All right, let's plug it in. Let's see if we get all motors on this one. Okay, so we get response from all motors. Let's power it up. I didn't get any sound. Or did my... Yeah, I didn't get any sound. Oh, that's probably... Oh, that's dumb. Yeah, that's because it's powered up already. Of course I wouldn't get sounds because it's powered up from the USB. Let's spin stuff. Okay, it's all sounding very healthy. So that's good. Everything spins, it's healthy. So now we need to test the UARTs. It's what I've been told doesn't work. Buzzer doesn't work and UARTs don't work. So we need to test this. That's when it becomes fun. And I'm saying fun, but it's actually awful. Because they're using... Well, actually, that could be quick if I find my WAGO connector. So the way it works, and I've been telling it, but probably should unplug this. But yeah, this doesn't have any pads to solder anything to. They only have that massive plug. And I will show you in a few minutes the wire harness that give you. And it is both glorious and absolutely ridiculous. And you can quickly understand why this idea hasn't caught on. It's just, yeah, not great. But we will see if we can get some UARTs working, some UARTs not working. We'll see if we can fix them. It's possible that it's just a resistor that's broken in between the UART and the MCU. It could be the UART is dead on the MCU. It's a good investigation. But, so that's the chip. And this is the plug. And this has everything. And let me show you the wires. So this is the thing that gives you, apparently, but yeah. Isn't this absolutely glorious? You get a wire harness with 1 billion wires and you're supposed to deal with that. And what do you do with the ones you don't need? Well, you just leave them floating off? Or can you deepen those? I don't think you can. Let's see under the microscope. It's a thinner kind of cable than we used to. Yeah, I don't think you can just... Maybe you can deepen them. Maybe you can. I've never done it though. Don't know how it works. But that's not what we're doing here. Here we're gonna need to find which one of those matches this and try stuff. And what I was thinking is, instead of soldering, we could just try using Wago connectors. Oh, let me grab some. I think I do have somewhere some Wago connectors. Those electrical things. Yep, I did find a few. I'm gonna need probably 4. Yeah, there we go. Gonna try using those so we can quickly reposition stuff, and I can leave that plugged in. I'll plug it in now, and I can leave it plugged in. And that's just asking to be torn off, and then your whole ESC does nothing. It's just dumb. It's incredibly dumb. Also, like, you have to unwrap that neatly rolled cable just so we can know what stuff goes where. It's just so dumb. Oh, the whole thing is just incredibly stupid. And yeah, okay, so let me unbraid. What did you do tonight? Oh, I just unbraided my harness from my NewbeeDrone AIO. No, it's just done. Who doesn't want to have to deal with that in their quad? No, because it's not. Well, quads are too simple, you know. So yeah, now I have hair. My AIO has hair, and I do. And the person who sent me this, whose name is 3DX, also had the thoughtfulness to also send me the thing. The diagram, so I don't have to look it up. All right. So what we'll want to do is test a bunch of things. Let's test the buzzer first, because that's easy. Let me grab a buzzer and confirm that it works, because some of my buzzers have been sitting in a drawer for a while, so they may not be the most up to, like, charged all the way and everything, but I'll try this. So, oh, actually, that's a good occasion to show you how those buzzers work. It's very simple. So that's a ViFly Mini. They all work the same, those battery-powered buzzers. I have 3 wires, and one of them goes to 5 volt, one of them goes to ground, and the yellow one, when it's pulled to ground, will make the buzzer beep. So what I'm going to do is go to 5 volt on my PSU, quite increase the amps a bit, and I'm going to clamp on red. So here we're trying to ensure the buzzer works correctly. So here, when I give it juice, the thing should light up and start not buzzing. It does. And when I touch this to the ground, it should beep. It does. And now if I unplug it, it's going to do the beep. It's going to do the sequence. When I plug it for 5 seconds, and then it stops. Okay, so we know the buzzer is good, which it should. I mean, it's a spare, it shouldn't go bad. But they do drain a tiny amount of battery, microamps, just sitting in the drawer. So after a year or two, the battery is going to be empty. All right, so now we want to connect this to this mess. So what I'm going to do is select one to be ground, one to be 5 volts, oh. Why can I not get it to stick? I mean, it's not designed for thin cables like this, but it should do it. Should work. There we go. They're like magic, those connectors. They hold on to the wires really well. They have great current capabilities. I'm gonna need to kind of strip those a bit more, the NewbeeDrone ones. But let's see which one they are. So we're gonna need a buzzer plus, buzzer minus, and a ground. So ground, the first one is ground, one of the black ones. Good. At least black is ground. Let's see if I can strip this a bit more without, you know, kind of breaking it. It is extremely, extremely thin wire. And it is extremely hard to strip. Is it one of those that's not silicone? I can just burn it away. Okay, there we go. I have managed to strip it. So that's going to be ground. Grab my ground. Oh, it's not holding good enough. Those are too thin. Oh, it is holding. Let's see if we have continuity, just to make sure. Can I probe this? I just want to make sure my connection makes sense in terms of using the wagos. So this black here, which is the termination for the buzzer, I'm going to probe into that, and I should be continuous with minus here. It is. Good. Okay, just need to strip and connect. So buzzer plus is the 5 volt red wire that's here. Why am I even repairing those? Who's going to want to deal with that stupid mess? Oh well, maybe someone will, if it's cheap. There we go. And now we need BZ minus, which is the next wire. And that's why I'm going to have to use my tweezers. So the next wire down after it's this green one. I have managed to semi-strip it. It's just misbehaving. Oh well, I'll just cut it at the end here. There you go. Stripped. And hook that up to BZ minus, and Okay. Now, if I give it juice, it should do some beeperoos. And I mean, isn't all those wires laying about, are they asking to be shorted somewhere? It's just, they are asking to be shorted. I'll try to fan them out so they don't get shorted stupidly, but and they are fanned out. All right. We still have, let's go to 16 volts. We're still on OCP. Let's see. Okay, that's flashed, so that has 5 volts. And I will do the beeper. But can we trigger the beeping from the command? And let's see how it's configured in terms of buzzer. So let's have a look. Configuration. And yeah, so it has all the things enabled, right? Oh, USB. So I want it to be able to beep on USB. Bat low. I mean, I should be able to trigger beeping. What I can do is just hook up an RX to it, and then we'll be able to trigger the. Sorry. Oh, shit. Maybe disable the buzz. What I'm going to do is hook up an RX to it, and then we'll be able to make it beep. I just have to apply my preset on it so it has my modes. Let's do that quickly. We'll need to set up the ports. I'm guessing one of them is UART1 is set up to RX, so we'll hook up to UART1 presets. I'll go for my preset has my modes, so we'll set up stuff. Yeah, doesn't matter. And okay, let's hook up UART1 to a receiver, and I do have a small receiver already bound to my yeah, that's the one. That's a small one with a ceramic antenna. It's already bound to my radio. I should be able to just simply solder to it. Let me grab my Oglifixo. We'll find out what UART1 is on those plugs. So if the buzzer is not buzzering, it's probably a transistor that's burnt or something. There is a small transistor that serves to pull the signal wire to the BZ minus wire to ground. The reason it's done through a transistor is because you can run active buzzers, which are buzzers that beep when you give them 5 volts. And those can require quite a bit of current. So the way you ensure current is being able to be delivered to the buzzer is to use a transistor to kind of open the gate and let big current go through, because if you hook up to the MCU directly, you run the risk of burning the MCU. So let's see which one's ground. Yeah, that's the ground is the one on this side. Okay. Now, what's what, brother? You want one. Why is there no UART1? Looking at this, I can see UR3, UR7, UR3. Where's UR1? Is it on this plug? That's bound to be the VTX. The fuck? All right, let's hook it up to, you want another one? So I can use any black, any red, and let's do UR3, and then we'll set it up. That way we're testing UR3. So let's hook up a ground and a VBAT, 5 volts. 5 volt here, ground here. Tweezers, there. That's a ground here. I'm just gonna brute force it without tinning the wire first. Should be more than enough. Yep. It might actually be factory tinned. Good. Now we need to find UR3 wires. So it's after the second 5 volt, it's the third wire for RX. 1, 2, 3, so white here. Okay. So RX, so that goes on TX, so that's the next one in the list. There you go. And so that's UR3, and the next one is UR3 TX, that goes on RX. So the green, there's green cable. Are we having fun yet? I feel like I managed to put everyone to sleep with my dumb NewbeeDrone AIOs. Yeah, they're not mine. They are my repair though. All right, we have an RX doing its RXy stuff. Let's see if we can get signal. Does it even light up off USB? That's a good question. I expect it won't, but it doesn't. Okay, so gonna get my radio. And give our boy some juice. And hopefully we should see the RX light up here. It does. Yeah, it blinks. I need to put this in ELRS mode. And I think they're bound, so it should bind. Just takes a while. If it's not. I mean, there's a world where it's not bound to my radio. Which point, I mean, if it goes to Wi-Fi mode, I'll do it. I'll do the quick bind phrase. Might be that I lent the quad before I disassembled it, the quad that this was on. So it might not be ready. So I'll wait for it to go to Wi-Fi mode. Let's go and set up the thing to be on UR3 ports. UR3. Right, so let's blinking all the way. I'll do the bind phrase thing with my phone. So just for those who don't know, I mean, I'm pretty sure all of you know how to do a bind phrase, but yeah, it doesn't have a bind phrase. I'll put mine. Save and reboot. And that should bind to my radio. There we go. Now we'll check whether we get signal. Which I never can find the receiver tab. That's not moving. That is indeed not moving, which, as far as I was told, was possibly the issue. Okay, so let's see if we can get something working out of UART 7, maybe? Yeah, the 7th. Oh, shut up, buzzer. The 7th UART, maybe? Or we'll try UART 7, so that's. Oh, UART 7 it only has TX, so it's meant to be for analog. I'm guessing though, yeah, so it's meant to be for analog. And when there's no RX, so let's, yeah, it has a camera input as well. So let's go for UART 8, RxTX. So let's try that. And I'll desolder those two quickly. Right. Which one are we looking for? Looking at. So that's the two before the end, I think. Last one is LED and TX, RX, the last two before the end. So the last one is a white, then is a green. So it's going to go to our RX. Next one is a white. So that goes to, so that's RX, goes to TX. Actually, I don't need a tweezer. And then the green wire goes to RX. There we go. Let's see if this works better. So USB. Now we want UART 8. I didn't check that this was set up for ELRS, but let me check quickly. Because if it was set up for S-Bus, it would never have worked anyway. And, oh, actually it might have been, because UART2 must be in the plug. Yeah, it's set for S-Bus. I'm dumb, so maybe the other UART works. But first we need to flash this with the right target. Of course it doesn't detect because it's NewbeeDrone. It's, I think it's the Infinity AIO. Yes, it is the Infinity AIO. And let's go for a known resource. Let's go for this version. And we want CRSF and digital OSD. Yeah, I kind of knew it was S-Bus when I realized that UART1, which it was set up for, is in the digital plug. It must be the UART in the digital plug for S-Bus. So that explains why it would have not worked. And let's load and flash. Why is this pending? Why is nobody failed? Please, let's see if we can, if it works on the latest. Might not be a target for the other one. Okay, that worked. That works fine. The target is unknown because NewbeeDrone is just can't be bothered doing things correctly. Right, that should mean our thing is what's going to be working, hopefully, and then we can test UR3 again. Can test if our buzzer buzzes. Then we can fix the buzzer. And I'm going to have a bit of water. All right, it's back. Yes, and accelerometer isn't calibrated. Let's calibrate it. So it's, no, that's not calibrated, doesn't matter. Modes, presets, ports. RX is on UART 8. Save and reboot. Okay, shut up. I am going to calibrate it just so it doesn't, so it stops bothering me. And then receiver, let's give it juice. My radio should be, yep. Covered. And stuff works, yay! All right, let's try the other UART. Oh, let's see if, actually, let's unplug the USB and see if we can get it to beep. And we'll power it off. Remove the USB. Power it on. Looks like it beeps. Yeah, I mean, that's beeps. And if I use my... Wait, it doesn't. Oh, because I didn't put my modes again. Dumb. Let me put my modes again. But we know it's beeping. I mean, I'm just going to confirm it in real life, but just because it's how you should do it. But it did beep at start, so it's the beeper's working. Okay, and now we can unplug it. Shut up, beeper. And plug it back in. Now we have telemetry recovered. It doesn't beep. Did I? Telemetry lost. Ah, no, it didn't beep. It did beep before. Telemetry recovered. Oh, of course, because my... Interesting. Okay. It didn't beep again because my preset removes a bunch of beeper modes, but it doesn't remove the beeper set mode, which should have gotten it to beep. So let's have a look. Let's have a look. Here, if we go to modes, we should see Oops. Yeah, so beeper is done. So it did work for a second, and now it doesn't work anymore. And if we go to setup, we tell it, sorry, configuration, and tell it to beep during when USB is on, it should beep. Oh, it does. Is it something done when it thinks USB is connected when it isn't? I don't know. Let's try off screen. So now the thing is just powering up, not beeping, radio, and I can get it to beep. So the beeper circuitry works. That's what we want to know. So let's see if the next UART works. We can unplug that dumb buzzer because it is annoying. Okay. And this can go back into its little box of spares. All right, let's try again on the UART 3. Double check that this works. And then I have kind of a suspicion onto what made him think the AIO was broken. So that was third one from the middle 5 volt. So this guy, 5 volt, yeah. Third one, yeah. And then the next one is over here. Right, let's go check. So we want to put that onto USB UART3 ports, UART3, save and reboot, and let's see if it moves. Receiver, and it's double checking that the cables aren't shorting. Give it some juice. Radio should come on, and we have motion. So the UARTs are working fine, and the buzzer is working fine. I think the AIO is just perfectly fine, but we'll have an idea of what to check, why they thought the AIO was broken. But at the moment, it's completely fine. There's nothing wrong with this AIO. Let me desolder this. What I think is, I'll show you, but they made a custom harness that kind of binds those wires from the harness to other wires. I think that's the thing that got damaged, and the problem wasn't from the board. It was from the wasn't from the board itself, but it was from the I can't find my words today. It would have been from the wire harness, I think. That is my suspicion, but I will try and verify this, because I do have the cable, so let me show you. So they sent me this, which is probably all the wires from NewbeeDrone, but that was this thing. And this has a bunch of connections. And I think the connections might have been the thing that failed, because This would have been, for example, the buzzer. So let's see if I can get continuity between the buzzer thing and the harness. And I don't know exactly which I don't remember which one it is, but I'll tell. So that's the ground here. I'll go here and test all the grounds. I'm going to use my Omnifixer again to hold the plugs so I can probe them. Because it's otherwise very annoying. Okay, so I was saying, let's see. Ground here, and we'll see if we can get continuity from one of the grounds here, or we get from here. Then the second one is one of the 5 volts. Okay, yeah, that's feedback, and next to it. Now I get continuity, so I don't know. I don't know what would have happened. Maybe it had corrosion bridging some things, and I did thoroughly clean it. So that might be it. But as it stands, this is a fully functional board, I believe. So yeah, I don't see anything wrong with it. So that's going back. That's going in the box. Straight in the box. So that means we don't have a donor, so we need to flash the other one. And so what we'll do for the other one is we'll do the graft of the MCU, and then I'll need to, I don't have all the software. I don't have all the software installed to flash AM32 onto that PC. I also don't have everything set up for flashing, including like the ST-Link setup, and I don't know what the target is, etc. So I'll prepare that off stream. So what I'll do is right now we'll transplant a working MC on this, and after that I'll take it off screen, set up everything, and next stream we'll flash it and make it run. I'm sure I can find the target for it. Hopefully it's public. And then we'll have 2 functional AIOs. And drop my radio. And yeah, let's do a quick donor swap of MCUs onto this board. So this is our donor. And let's take one that looks good. That one looks good. Blast it with air. Let's go. Get some tweezers, get some hot air. Let's go a bit higher on the 70% airflow. Should do as good. Now, heat up the board a bit. Well, it probably doesn't matter much because this board is a donor. Just waiting to see stuff melt. It has started. Mostly melted. I'm guessing ground is the thing that's still yet to melt. Don't want to pull. You don't want to pull because you could rip pads. There you go. Ah, interesting. This one might not be the right donor because it's G8, not GB. Oops. I managed to lose it. I'll find it at some point. It's here. It doesn't have the heatsink under it, so I don't think that's the right donor. I don't think that's the right chip. I was a bit too quick to call it, but yeah, it doesn't have the pad under it, so it's not the right chip, the same chip. So that's going to side, and I will resume looking, because that's G071G8, and what we want was G070GB. And that's definitely a B, not an 8. Yeah, we can see the 8 next to, in this font. This is the 8, this is a B, so it's not the right one. We want a GB, so we might not have one. Let's resume looking in the parts bin. I'll pull that out. And I'll bring some of them onto the screen. I'd like to, so we said that was R3, yeah. That's 8-bit, I think. Yeah, that's 8-bit. That's 8-bit. 8-bit. 8032. 8-bit. R3. Yep. 8032. R3 and 8-bit. I have, well, I think I just moved that ESC from my donor board box into my to repair box, just because I think it's repairable with my current skill. But what we can check is some other stuff that I might not be repairing anytime soon. This one, for example, 8032. I have a bunch of 20 by 20. That must be, yeah, that's 8-bit. 20 by 20 AIOs. Yeah, that's the one. That's the Sky Stars. I think it's repairable, but does it have the chip we need? It's hard to read. G08N, not GB. 8N, yeah. That's not the right one anyway. What's on this guy? 0F. Huh. Well, might be that we can't. That's 8-bit, I'm guessing. Yep. More chips. This one I'd like to repair anyway, but let's see. 8N. This one is mine, I want to repair. Okay, so we do not have a donor, so basically this is gonna sit on a waiting for a donor list, or I'll check if I can order one, if it's cheap. It's very possible that it's cheap. I think I can get one, but unless I can get one, this is gonna sit on the sidelines for a while. I'd rather not spend much money on it, because I don't know if it's actually going to fix anything. I don't know for sure that it's fixable. So we'll see. We'll see. We'll see. So what is next? What are we doing next? Would be good to get some more flight controllers. However, the issue is there isn't many flight controllers left in the box. I think there's one, so we can have a look at that one. So here's the flight controller box. Yeah, it's pretty bare, so if you guys have flight controllers that you're not doing anything with, send them my way. I have a bunch of 20 by 20 stuff, but pretty much everyone I fly with flies on 30 by 30, so we'll see if we can get this one repaired. Let's see if we can do this quick, and then if I can fix this quick, then I might call it a day. Let's see. Let's do the normal stuff. Let's go for a visual inspection first. I'm betting this is just a dead back or a dead MCU, but we'll see. All right, so can we see anything crucial? That's one gyro. Component sounds very straight, but that's not really anything to worry about. Two bags are here. MG, I have some of them now. I've ordered them. Yeah, very simple board, should be very easy to diagnose and fix, hopefully. We can do a quick capacitor check, just in case something's shorted. Nothing's shorted. Ground, where's the ground? Checking the rails are shorted. Nope. All good. Right, let's plug it into USB. I'm being careless. I'm not using the FNIRSy thing today. Okay. Oh, I saw something. Oh, now it's working. Okay, it's working. So it was just a bad connection. It is working. And I can connect to it. Let's see, the gyro is working fine. Ah, not fine. Okay. Is that overheating? It looks like something is overheating. So it's still blinking, but it's not communicating with the... Is it communicating with the... Yeah, so we've lost communication. Or is it just a dirty port? I think it's just a dirty port. Let me clean up the port a second, quickly. We'll just heat up the port quickly from above, and then squeeze some IPA into it and brush. Just doing this to loosen some old flux. So I don't want to heat up too long because it is 400-degree air. So it could loosen some stuck-on flux. Make it easier to clean. I don't know why, but I have a suspicion that there might be something overheating. So I am going to put some the thermal cam on it, just in case. I don't know. We'll see. Let me plug it in. Oh, what's this next to the cap? It might just be the normal diode. It's not that hot. Can I get the temp? only 42 degrees, so it's not crazy. And I think that might be the diode that powers the... Yeah, the temperature is not going crazy. And let's see if I can get a solid connection in there. Okay, so it's not overheat. Oh, it has lost it. Has lost the plot, and it has lost the plot. And if I disconnect and reconnect, interesting. So let's have another look with thermal cam. Yeah, I can't connect to it anymore. Still have that thing overheating next to the cap, so we'll inspect it. We have, so that's just a regulator. That's just a normal regulator. I can show you better actually. So that would be, that's just the thing that powers the MCU, so nothing to worry about here. But this, yeah, this is not, there's nothing visually wrong with it, but it does, there is this part that overheats over there. And I don't know if it's normal, so what I would like to do is check another similar board, which I do have. It's my test board is the same, the one that's under this mess. It's actually the same board. So I can plug this one in USB and see if that one has an overheating chip. Yeah, has the same thing. You can see a bunch of reflections, but yeah, it has the same thing. So the fact that this is disconnecting, let's try a reflash on the other one. You can put that back. Let's try a reflash just in case it's a software issue. So what are we going to do here? So we should be able to go here, check what type of board it is. Oh, USB not recognized. Uh-oh. So I'm pretty sure it's a DAC, yeah, DAC F7. So let's see if we can, I'll hold the boot, oh, the boot button is kind of stuck. I wonder if that had to do anything with it. Let me douse it in IPA and kind of action. So the boot button felt really stuck. And I wonder if that has anything to do with it. Could kind of get stuck in a weird, half-connected state. I don't think so. I'll see if it gets recognized now. No, USB not recognized. I have a feeling that the MCU is toast. But we'll put it in boot mode and see if we get, and so now it's in boot mode. I did appear immediately in as a bootloader here. So I'll flash it. And it's a DAC F722. Let's see if it flashes right. And if I can get it revived, I'll try to make sure I'll leave it for a few minutes and see if it still works after a few minutes. But if it doesn't, then it's probably just an MPU swap. Okay, verifying, so that's good. Betafly STM electronics shows up. Okay, so that's better than what it did just before. Now we just need to see if it keeps working after a while. Was it just a flash away from working? That would mean its memory got corrupted somewhere. Can happen. Well, that seems solid for now. I'll leave it to the side. Yeah, I need to test the Bex next. So I'm gonna find my Beck, my connector here. And make sure it's pinned correctly. That's still working. All right, maybe it was just that. I mean, nothing's overheating. I took the flash well, so that is something that can happen. I've seen it before. People have been flying on stuff I repaired like that. So here we just need to make sure this matches correctly. And that is correct. No, that's the other way. So I'll dip in this. I'm keeping it connected. Yep, I'm checking on my screen that the thing still works. And it does. Maybe it was flashed with the wrong target and something. Yeah, I don't know. I do not know. So ground is on this side. Ground is on your side. Set up. Okay. Yeah, it's still moving fine. So yeah, I'm guessing it was just a flash. Right, let's give it some juice and see if the Bex are working. Ground and VBAT. It feels like it hasn't gone in as it should. Let me double check there's no bent pin. There is no bent pin, so that's just me not pushing it all the way. Right, maybe grab my XT adapter. Where is it? Here. I need my XT60 to XT30 converter, which is somewhere here. Up. $16 volts. Moment of truth. Yeah, that's working. And we got all rails. So yeah, it looks like it's fixed. That was an easy one for once. So it wasn't actually broken, but it kind of felt like it was. Interesting, interesting. But yeah, good one for the box. I need to make sure I have some of those stupid wires as part of the box for this AIO. I might keep it outside the box and have it on special request because, yeah, it's a bit of a weird one. Okay. All right, so one AIO was working, one FC was working when it needed flashing, and we figured out what was wrong with this one, but it needs a part. So I'm gonna have to look that up, see if I can buy one for cheap, and I'll come and fix it on the stream. Also, if I do, I'll make sure I have everything installed to flash AM32 and show you guys, or at least have a reference online for what's happening, how you flash AM32, even though there's plenty of good resources on the internet for that. But I think I am going to call it a bit earlier today. I have a bunch of things I want to do, and I don't have anything pressing for repairs. However, next week I'm looking into some Fat Shark goggles that need repairing. Someone on Discord said they had no other option. I tried to have them repaired locally, but couldn't get it done. So you are not focused. I am not focused. That's the camera does it. Good enough. Good enough. You don't need to see every single detail, do you? Yeah, so Fat Shark goggles, I don't remember what the issue was. I think it's a no power. So we'll be looking into that in next video. And I have never looked at goggles. So yeah, I'm going to be looking, see if I can understand how it works and see if we can figure it out and see if we can get it back in working order. I also have a couple of GoPros I might look into. I've started opening one and it looks, I mean, I found a short, so I'm probably be able to figure out where it comes from, fix it and see if it fixes the GoPro, but those boards are absolutely tiny and with so many components on them. So maybe we'll do depending on how we get on with the Fat Shark goggles, we'll see what we can do with the GoPro. We'll see. But yeah, it's going to be a bit different next week. So make sure you're around for all of that fun and investigation. Hopefully you enjoyed the stream. If you did, remember to click the like button, it really helps. And in the meantime, I'll wish you a very good rest of your evening, and I will see you later. Have a good one, guys. Bye.